So we know what we are going to do. That's the strategy that was the previous video. Now we're just going to see a little clip here on how we're going to organize the work. Remember that when we did row operations and found the LU factorization of matrices, that took a good deal of organization. I think that the biggest downfall for some of us was not just not being able to do the math. I think we can do the math. I'm confident in that. It is the organization that we need to be careful of. And so when we go through the examples, please pay attention to the organization of where the numbers come from and where the numbers go. It's that information management that is the greater skill than just being able to crank through this stuff and get the answers. So here's a picture to help see the organization. For each AI, write it as the sum of the first I of the QK projections. That line is very loaded. The equation underneath it is a more detail-oriented way of seeing that. The AI is the summation from 1 to I of each of those projections. On the strategy, we saw that to come up with a QI, we're going to subtract all the projections. If we just add the projections to both sides, we get what's in this box. This is expanding the summation notation. AI is going to be the first component, the second component, up until the ith component. Remember when we had the picture before in 2D, there were 2 components. In 3D, there were 3 components. By the time we get up to this ID, little I dimensions, there are I components. And we would keep going. In the next one, there would be I plus 1 of these terms, these projection terms. So now here's the matrix way to organize all these different equations. Each equation is for an AI, and each one of those gets its own, each AI gets its own column, and this is the matrix that we call A. And each of these columns is made up of columns from the new basis that we're finding, the Q hats. And when we combine columns to get new columns, that's matrix multiplication from the right. And so we see here that for the first A, A1, we just use Q1. And so that's the projection into the Q1 component. To get A2, that has 2 components, a first component and a second component. And we see that in this matrix, we just have 2 entries to describe how Q1 hat and Q2 hat will combine to give us A2. So notice beneath all of these is zeros. This matrix is upper triangular. It's a nice structure, upper triangular. And you can see these entries are very systematic. It's always the projection from the Qith component of the ajth new column. This matrix we call A. This matrix we call Q. And this matrix we call R. A equals QR. So before A equals LU, solved one problem. AA equals QR solves this problem. We're mostly interested in finding the Q's. Just like in LU factorization, we're mostly interested in getting to upper triangular, but the R stores this information of the projections, just like the L stored all of the information of what row operations we were doing.